So in this video, we are going to start with a new chapter, chapter number 2, called as polynomials. So this is the title of the chapter. Now the first thing that we're going to understand in the introduction video is what is a polynomial? What exactly is the definition of polynomial? Okay, so let us start with simple examples. Now consider these terms x, y, z, or consider this a, b, c. So we have seen these terms or these symbols before, and typically in algebra these things are called by variables. Okay, so as you can see that this x, y, z, or a, b, c, or we can go ahead, we can take any random alphabet from our 24 alphabets, 26 alphabets, p, q, r. All these things are collectively called as variables in algebra. And typically in algebra we tend to find the value of these variables. They're used to denote unknown values. Unknown values are used are denoted by these variables x, y, z, or a, b, c, or p, q, r, and so on. Now, once we know these are very simple units called as variables, now we'll go one step ahead, okay, and we will write something called as 2x, okay, or something called as 5y, or minus 3z, okay, or let me also use fractions here, rational numbers here. I can write 1 by 2a, okay, or I can write 3 by 7b, or let me write minus 8 by 15c. Okay, now as you can see, these variables x, y, z, or a, b, c, these variables have got a constant. So this variable has got a constant here. These are the constants that has got attached with the variable. So in algebra, these things are collectively called as, so let me mark an arrow here. Yes. So these things are collectively called as algebraic expressions. So what is an algebraic expression? It's a variable with a constant. A variable with a constant. Okay. These were plain variables. They did not have any constants attached to them. If you attach constants to them, they are called as algebraic expressions. Now, we can clearly see that these algebraic expressions have a definite form. Okay. All these algebraic expressions, okay, they are all of a form, and that form is nothing but, I'm going to write here, the form is nothing but constant, okay, some constant value multiplied by some variable. Okay, so in fact we can say that this is the definition of an algebraic expression. What will be an algebraic expression? Very simple. An algebraic expression will be a constant which is multiplied by a variable. This constant is any number. It can be a whole number, okay, it can be an integer minus 3, it can be a rational number 1 by 2, 3 by 7, minus 8 by 15. So all the algebraic expressions are of the form a constant multiplied by a variable. Okay, now let's go ahead and let's now try to see more algebraic expressions. These were the simple ones which we saw, quite easy to understand. Now let's make it a little bit complicated and see different type of algebraic expressions. So I'm going to write one by one. Consider this x square, okay, or comma 2y cube, okay, or minus 8z raised to 5. Okay, so this is one set of algebraic expressions. Now I'm going to draw a line here, okay, and I'm going to write another set of algebraic expression. Consider this x raised to minus 2, okay, or 2 raised to y, sorry, 2 into y 3 by 5, okay, or let's say minus 8z raised to minus 7. Okay, now you can clearly see the difference between these three algebraic expressions and these three algebraic expressions. First of all, let us confirm, let us be sure that these are indeed algebraic expressions. So what was our definition of algebraic expression? Constant into variable. So if you look at all the 6 algebraic expressions, they have a constant, they have a variable. They have a constant, they have a variable. Okay, here the constant is 1, variable constant variable. Now, what is the difference between these three and these three? Yes, the difference is the value of the exponent. If you focus on this exponent, all the exponent on the left hand side are positive, or let's say I'll write here the exponents are whole numbers. Okay, here the exponents are whole numbers. They are not rational numbers. Here the exponents are whole numbers. Whereas on the right hand side, you can see that the exponents, okay, the exponents are rational numbers. Here the exponents are rational numbers. Okay, now this is the main difference between these three algebraic expressions and these three algebraic expressions. All the six are algebraic expressions. Note that all the six expressions are valid algebraic expressions. But if your algebraic expression has a whole number as its exponent, okay, then we will call those algebraic expressions as polynomials. Simple. These are all called as polynomials. So I'm going to write here polynomials. Okay. Whereas these expressions, they are not polynomials. So I'm going to say they are non-polynomials. So this is a simple definition of what is a polynomial. So what is a polynomial? A polynomial is an algebraic expression whose exponents are whole numbers. When we say whole numbers, 0 is also included. That's a very important point. Which means, so if I say 2x raised to 0, this is a valid polynomial. If I say 2x raised to 1, this is a valid polynomial. If I say 2x raised to 2, this is a valid polynomial. Okay, it has to be a whole number. So whole numbers, as we know, whole numbers, they start from 0, 0, 1, 2, and so on. So as long as the exponents are whole numbers, it will be called as that algebraic expression will be called as a polynomial. In this whole chapter, we are going to only focus on polynomials. So such expressions, such algebraic expressions are of no use. They are of no concern to us in this whole chapter. Now let us see some more complicated examples of polynomial. So for example, consider this 2x square plus 3x plus 5. Is this a polynomial? Now that's the question. Is this a polynomial? So to check if a algebraic expression is a polynomial, we have to just check the exponents of the variables. Okay. So the exponent is whole number. Here the exponent is whole number. Here also the exponent is whole number. Okay, because this can be written as x raised to 0. Anything raised to 0 is 1. So x raised to 0 is 1. So since all the exponents of this algebraic expression are whole numbers, this is a valid polynomial. Okay. Now let us see one more example. For example, y cube minus 3 by 5 y square minus 33 by 89 y plus 17. Okay. Now, is this a polynomial? Yes, it is a polynomial. Again, why? Because the exponent of every variable, the exponent of every variable is a whole number. Even if there is one variable, even if you find one variable with a whole number, with a exponent which is not whole number, then it will not be a polynomial. So again, this is a very valid example of a polynomial. Let's consider an example which is not a polynomial. So let me draw this line here. I'll continue this line like this. Okay. So example which is not a polynomial, for example, yes, consider this 5a square minus 7a cube plus a 3 by 5. Okay. So here you can see that this is a whole number, this exponent is whole number, but this exponent is not a whole number. So even if there is a single term where the exponent is not a whole number, we say that this is not a polynomial. It's a non-polynomial. This algebraic expression is a non-polynomial. So thus this is the concept of a polynomial. Very simple. A polynomial, just to revise, a polynomial is an algebraic expression, okay, where the exponents are whole numbers.